So in this problem, we are given the marginal demand function d prime of x, and we want to find the regular demand function given that d is 13,000 when x is 4. Okay, so this is a graph of the marginal demand function, but that graph really doesn't matter. What we're going to do is integrate the derivative of d to find d. So d of x equals the integral of d prime of x. And that's going to give us an indefinite integral. So what we'll do is use this 0.4, 13,000 to find the plus c in the end. Okay, so the antiderivative, we want to find the antiderivative of negative 1200x over the square root of 25 minus x squared. Okay, so this is too complex to evaluate using normal methods. So we're going to have to use a u substitution. I'm going to choose to let u be, well, it needs to be an inside function whose derivative we see. Now, one option might be to use the entire denominator, and you might be able to make that work. But you're going to have to use the chain rule to differentiate because you've got the square root of a function, which makes it a complex choice. Instead, I would go with the part inside the radical, 25 minus x squared. Its derivative is negative 2x dx, and we have a negative x on top and a dx, so this is good. 1200, let's split that into 2 times 600. So we're going to pull the 600 out front and write it as 600 times the antiderivative of negative 2x over the square root of 25 minus x squared dx. Okay, so then we can go ahead and substitute in u and du. So since du is negative 2x dx, all of this part becomes the du. And then what's under that radical is our u. So we're going to have 600 times the integral of 1 over the square root of u du. It's going to be a lot easier to anti-differentiate if we write it as u to the negative 1/2, because then we can use the power rule. So negative 1/2 plus 1 is positive 1/2, so we have 600 divided by 1/2 times u to the 1/2 plus c. 600 divided by 1/2 is the same as 600 times 2, which is 1200. And then we have times u to the 1/2. That means the square root of u. And let's go ahead and plug back in u, 25 minus x squared plus c. So that's d of x, but we don't know the constant c. So that's where this point 13,000 or 4, 13,000 comes in. Let's go ahead and plug this point in right here. So that means that when x is 4, d is 13,000. So we have 13,000 equals 1,200 times the square root of 25 minus 4 squared plus c. And we're going to solve that equation for c. So we need 13,000 divided by 1,200. I'm just going to do this on my handheld calculator. It's not a, well, it's a decimal. It reduces 13,000 divided by, oh, wait, actually. We can't do that. I don't know what I was thinking. Can't divide by 1,200. We have a c here. Okay, so let's just compute this. Okay, so 25 minus 16 is 9. Square root of 9 is 3. There we go. Let's do 1,200 times 3 is going to be 3,600. Oh, plus c. 3,600 plus c, and then we subtract, not divide. Don't know what I was thinking there. So 13,000 minus 3,600 is 9,400. Okay, so I'm going to come back up to, let's see, this right there. So therefore d of x should be 1,200 times the square root of 25 minus x squared plus 9400. So let's give that solution a try over here.